Greetings. Some of you may remember that I took apart an APC Silicon DP320 UPS. I did a complete strip down on one of those a little while back. Well, I thought I'd take a look at some other UPSs. Now this won't be such a complete strip down on these, but it'll be a look inside and compare the differences between them. We've got quite a variety here. You can see there's 3 different APC units, plus an APC battery pack. There's an IMV, and there's also a Galatrek, which is probably going to be an interesting unit to take a look at. So let's crack on. I hope you like it. And first on the dissecting table, we've got this APC SmartUps 2200XL. And this is one of the early models of the 2200XL, which, as you can see, is quite tall. It's 5 rack units high, and we've also got, as a bonus, the 4 rack units high external battery pack. The XL means it can take an external battery pack. It's got a connector on the back which will take this, and it can take several of these because this also has a connector on the back, so you can daisy chain several of these and put them on the back to get much longer run time, depending on obviously how much kit you've got running. On the front we've got the on and test button. You press and hold it to test it, and the off button, and various status lights, which are common to a lot of the earlier APC UPSs you'll see in a bit. Behind this slightly broken flap we've got a test certificate and the battery compartment. And I've taken the batteries out to make this a lot easier to carry, and this one will take 4 17 amp hour lead acid batteries all down in there. That'll be 4 of those. And the battery pack takes another 8. If you're wondering what these are down here, they're foam separators. You get 2 batteries at the back, then you get a bit of foam, and you get the batteries at the front. And all the batteries plug in to these Anderson connectors. There's a matching connector on the battery pack. On the back you can see we've got the 48 volt connector, different colour to the ones on the front. We've got the grey ones on the front. The 48 volt one is blue. And there's the expansion connector to go on to the next pack in the chain. And over on the UPS then, you can see this is where the battery pack would plug in, if you've got one fitted. And we've also got the supply in, supply out. There's a large C20 connection, and you've got the smaller ones as well. And we also have then the management port and a smart slot, which can take one of these cards, such as this network management card, or this basic monitoring port card. If you need more cards to be fitted, you can plug one of these in and pop the cards into that instead. And if you have more devices that need to be connected, you can use one of these, which will plug in to that slot and provide shutdown control on up to 8 devices. Also on this UPS we've got the port here, which has absolutely nothing behind it. I think the larger versions will have a hardwired power connection in there. Anyway, let's take a look inside. Not really surprising that there's not much to see in the battery pack. It's mostly metal, with some connections on one side which are all bolted together into connections on the other. Well, here's the inside, and there's not an awful lot to see. There are 2 great big transformers at the bottom, and the primaries of these are wired in series. So the white wire goes down to there, the black wire goes through and spliced into the white wire, and then comes back up to here onto 2 of these heat sinks. The other 2 heat sinks, 2 of them go to battery terminals, although interestingly this one goes to the external battery terminal, and this one goes to the internal. So you've got the internal batteries are between this black wire here, the yellow, and then the red wire here. The external, this blue connection just down here, is these 2. So it's a separate connection for each. What I'm surprised to not see in here is a battery charging transformer. There's no transformer here separate to actually run to charge the batteries normally. So I believe these are used in reverse for actually charging the batteries, and not just as UPS transformers. The rest, there's not a lot to see. There's a few relays to cut the UPS in and out. The front panel is connected with a flat flex, which is soldered at both ends. It's not plugged in. And for those curious about those transistors, IRF 3710s, but I can't see what the inside ones are because the heat sinks are obviously in the way and everything's riveted together. It's a custom microprocessor here, and that's about it. There's a few coils and not a lot else. And that's the inside of a SmartUps 2200. A good time here now to put a shout out to FF Cosag, because he's done a lot more work with some of these SmartUpses, including some nifty modifications to them. So go check his channel out. I'll put a link in the description. Anyway, that is the 5U SmartUps 2200. The model number is SU2200 RMXLI Net, and the I means international. It's the 240 volt version. That was a SmartUps 2200 XL. Next up we have a SmartUps 2200 XL. Interesting, but this is a 3U high version, so it's not quite as tall, but it is a lot deeper, and this is a newer variant than you saw just now. Batteries are different on this. They go behind. All the batteries are in this tray, and instead of 4 of those, this one has 8 of those. 17 amp hour, 7.2. On the back, it's similar to the last one. One mains inlet, one high current mains outlet, 8 other ones. External connections for monitoring cards and such like. Internal slot for monitoring cards, and a slightly different connection for the batteries. As you can see, the terminals are different, and there's 2 of them. And if you're not using a battery pack, this goes in like that. And once again, we've got a fairly simple design. The transformer is now a single huge transformer at the front. Battery connections come through where they go through a fuse and straight out on the outermost terminals, where they'll go to the battery pack if it's fitted, otherwise they come straight back. And this one goes down to the board on a big terminal on the board, and this one onto that heatsink. And these heatsinks they're quite stiff, they're quite well spaced apart thanks to this spacer, because you really don't want these things shorting out. Custom microprocessor, Philips branded this time. Apart from that, it's broadly the same as the other one. You get these strangely tall electrolytic capacitors here, the set of 4 heat sinks with the connections going off to the transformers in parallel this time rather than in series, and that's about it. 2 more things. The part number of this one is SU2200 RMXLI 3U, and the battery compartment, as you can see inside, it actually runs the batteries as 2 sets of 4, so it's still a 48 volt supply. It's just got 4 batteries in parallel with another 4 batteries. Now, I won't test the 5U version of this because I expect the output to be the same on that. Current consumption is about 50 watts. I used to have a Tower SmartUps 2200 non-XL, and that used to draw consistently 60 watts off the mains. As I found out when I got a power meter, and it's like, oh, that thing's cost me 60 quid a year, I best turn it off when I'm not using it. Anyway, so you can see it's drawing about that much. So I shall switch it on. what's interesting now is if you watch this waveform, that's a little bit rough. That's the existing input waveform. But the UPS's own waveform is lovely and smooth compared to that. And with the UPS switched on but not running any load, you can see it's wandering back down. So there's not much of a difference whether it's switched on or switched off, to be honest. Let's give it a 100 watt load, and that's probably helping with the power factor, I should think, as well. I can switch that to a 1000 watt load. I don't know the efficiency of these if you're using it for load shift, for shifting load between off peak and on peak, because to do that I'd have to do a charge, a full charge and then a discharge, and see how much power I put in, which would be fine if the batteries weren't all shot to bits. These are 12-year-old batteries, and to give you an idea of how well they last, we've got the 1000 watt lamp on there now. And it's gone. So they're definitely on their last legs. One final test on this actually. This is with the batteries disconnected. The UPS hasn't realised the batteries are disconnected yet. It'll start bleeping when it realises they're unplugged. But the power consumption, assuming the batteries are fully charged and it's not even trickle charging, is about 30 watts. And now for something completely different. This is from Invertimatic Victron Energy Systems, and you'll see the newer versions are actually branded General Electric. It's an IMV-Net Pro 2000, and it's an online uninterruptible power supply. The mains is always coming in and being dropped down to the supply for the batteries and so on, and always going straight back up again and out. So the load is always fed purely from this. So if there's a mains failure, there's no interruption at all. It just carries on running. Around the back we've got an on-off switch, there's a circuit breaker, there's a 12.5 amp fuse in there, supply in, supply out. This can be removed to fit a management card, not the APC ones obviously, but the similar sort of thing, and this also allows remote management. And behind here we have provision for an external battery pack. And here's what it looks like inside. What you notice on this one compared to the APC is something missing. There's no big transformer in this. It's not on the other side, that's where the batteries go. It'll take 6 of the 7.2 amp hour batteries as you saw earlier on. So it's a slightly higher voltage system, but there is no big mains frequency transformers in here. What we do have is a pair of transformers here, and these capacitors are rated at 330 microfarads at 400 volts. So there's a clue as to how this works. Instead of creating a 50 hertz waveform and then stepping it up and chucking it out of the transformer, what this is doing is creating a high frequency, high voltage supply, smoothing it, and then using that to generate the 50 hertz waveform at mains voltage instead of at the lower voltage primary side. It's the secondary side. So it's basically acting like a high voltage amplifier, if you like, churning out 50 or 60 hertz. You can adjust which one you want. There's a microprocessor. There's a daughter board here which has the microprocessor on it. So you've got all the brains here and then all the brawn on the main board. I think this is a bypass relay here, so if it does detect there's problems, for example you're drawing too much current or there's some general fault it's found, it'll trip into bypass, and obviously you're not protected then, but at least the load doesn't shut down. If you're going to use this for load shifting, charging it up on economy 7 and running it during the day, be aware that according to the instructions this particular model only kicks out 1.5 amps on the battery charger. So you're talking about 110 watts of charging. So in a 7-hour period you're going to get not even a whole unit of electricity charged into it. So you're going to need an external charger as well as an external battery pack. And also worth considering, when it's switched off it's drawing around about 50 watts. Switch it on and that jumps up to around about 75 watts. Notice we've got a pure, nice clean sine wave there, and that's from the that's not the mains inlet. Because this is an online UPS, I can turn the power off and it's exactly the same. Efficiency, because it's an online UPS, is something I can check, because we're actually checking the power flowing into the system and flowing back out. It's not a line interactive UPS. That is going to make a difference. So here's a 100 watt light bulb. See, 100 watts out. Although interestingly, the unit thinks that light bulb is drawing 73 watts and 102 VA on the display. And for that 100 watts out, we've got 180 coming in. If I replace that 100 watt lamp with a 1000 watt lamp, it's a little noisier. 1006 watts, 1135, 1136, 37 coming in. And on the display, 1016 VA, 990 watts. Again, maintaining that pure sine. Unfortunately, those batteries are 12 years old. So if I want to run it on battery, the run time now is in seconds. Here's another APC, and judging by the weight without its batteries, I think this is another one which doesn't use a conventional transformer. Now, we've had other backups models in work in the past, and I think they're just cut down versions of the smart ups. I think they are actually pure sine wave inverters. This one isn't, and it warns about it on the bottom. Around the back, we've got one input, four outputs, two surge protected outputs which aren't UPS protected, they're just filtered, and we've got a network connection passing through to filter that. There's a telephone connection passing through to filter that, and there's a data port to communicate with this thing, which, looking at it, I think that's a similar port to the ones used on some of the newer APC ones. I think it's an RJ50. The battery goes in there, and is a pair of 12 volt lead acid batteries. And if you thought my other batteries were scabby, these are well past it. They've actually started a split. So let's pop this apart, because I will try it with a pair of batteries that at least has a chance of working. So we've got a sticker on there. There we go. So it's just a set of connections like that which are folded together. So you go between the batteries, and then the two batteries will stick together. So let's try that. Here we go, that's one. little bit of faff, but not too bad. That's the second one. And they will just stick together now. Using the label on the side. Oops. There we go, easy enough. Old batteries made by Long, different company, company in Vietnam. Which incidentally, CSB are now part of Hitachi and they're no longer made in China. I believe the last battery I had, which was a GPL series, and that was made in Vietnam. So before I power it up, let's have a look inside. And that's just got 4 screws on the back. And this doesn't appear to be designed to be taken apart because this actually clips in the front. I had to really pry hard on that and damage the case to get it out. But there's another 2 screws in here. And apart from the battery connector, so that's... Right, there we go. Oops, screws on the floor. And that's what's inside this one. Transformer which is held in by the just sandwiched in between the plastic top and bottom half. These are marked as clamp winding, that's marked as AVR, and that's marked as AVR as well. So this is for voltage regulation if the voltage is a bit out of whack, into a little bit of tap changing, I believe. So that's on top of the UPS functionality. So you got the UPS there, and then you got this AVR transformer here for trimming the voltage. The rest then is that's all plugged in on the board. But there's not much. Again, there's not much to see in here. There's another little transformer here. Obviously you've got the high voltage stuff here, and I'm mauling this. That's why I haven't plugged the new batteries in yet, because I didn't fancy this thing retaining some charge. We've got the relays here, which will be for the voltage regulation. Mains input comes through this breaker and straight in to the board down there. So we've got the line in onto the board, and there's the neutral. There's the white one there. So you got the supply on these connections here. The output, the surge protected output, the filtered surge protected output is here. So it's just past all the surge protection stuff here. And the output terminals are the orange and violet ones, which are down there, which are marked on the board as UPS out as well. There's a little APC labeled chip there, PD303. So it looks again like we've got custom chips controlling this, and again it's very simple. There's not a lot to see. Once again, the front panel is ribbon connected at both ends. It's not plugged in, it's soldered in. So you'd have to desolder it if you needed to get the front panel, if you needed to get the boards apart. Not that you particularly need to. 2 soldered in 30 amp fuses. They look like car blade fuses, and that have probably just been put in, soldered, and then snipped off from the back. Anyway, again, it's an example of a transformerless design. Apart from this, which the voltage regulation, the automatic voltage regulation is obviously not. Power consumption when it's off is quite low. That's probably just trying to charge the batteries. Ooh, that. Definitely not a nice output. Back to the sine wave again. So again, it's still pulling about 30 watts at the moment, but a lamp load like that, you can see it's helping with the power factor. I can't check it using this at the moment because this is watching the output, not the input. And once again, we can take a quick look at that modified sine wave output for the batteries back in. Would you want to use one of these for load shifting? Not with that output, not really. It's fine for running switch mode power supplies because the first thing they're going to do is just rectify that output anyway. They'll rectify it, smooth it, and feed it into a chopper. So, but you wouldn't want to use it for feeding transformer loads or anything like that. Not least because it's only 800 VA and it's rated on the bottom at 540 watts. So that's another one checked out. Next up, the Garlatrek Microback. Plus we'll take a look at its extension unit as well. This, despite its size, isn't a particularly powerful UPS. It's only rated at 1400 VA or 1000 watts. A lot of the space is taken up with the batteries. This will take 4 38 amp hour batteries, that's the big cube ones, and this one takes 8 38 amp hour batteries to extend the runtime of that. Round the back there's not a lot to see. We've got the mains input and output, and for the battery pack a mains input. This would normally be cabled through to that. When I took these out of service they had a 4 square mil mains cable linking the two. And we've got some RS-232 interfaces and a big service port as well that you've got to refer to the manual for. And also on the back we've got these two battery breakers. Now this is a ferro-resonant UPS, hence the rather strange and rather hefty transformer. And oddly enough in here as well we've got these two capacitors as well, which are rated 22 microfarad at a whopping 930 volts. This transformer, I've counted at least 20 terminals between the top and down the side and up the bottom as well. There's a lot of connectivity on this thing. It's a really strange way of working, but I'll post a diagram here which I found on the internet showing the rough operation of a ferro-resonant UPS. And a very complex transformer seems to take a very complex circuit to control it. That just connects to the front panel. We've got a 68HC16 CPU along with a 1 megabit EEPROM, and there's a 28C16A there as well. There's a few transformers on the board as well. These have steel laminations, so I suspect those are mains transformers of some sort rather than high frequency stuff. And obviously there's not much else on here, but it's clearly quite complex to control if it's got that much EEPROM, which I shall of course dump. The battery terminals from the bottom, you can see you'd normally have 2 batteries here, then a tray. This tray would go, well, this insulating board would go on the top of the whole thing. This tray separates the lower 2 batteries from the upper 2. And the battery connections come in here. Interestingly, the 48 volt supply from the battery also goes straight to the transformer. The negative side of the battery is connected to ground, so if you were using an external power supply with it, it is ground reference, it's not mains referenced, so it should be relatively easy to run with either this other charger here or anything else really that can churn out 48 volts, apart from possibly Telecom's supply, which would be a minus 48 volt, which is ironic really because Telecom's kit is what this used to run. So yeah, it's quite an interesting device. Let's take a close-up look at that transformer. You can see there's a lot of connectivity. We've got this ring of connections all around here. There's those ones on the side there, there's small ones, and there's two further down, sorry, there's four further down, which go out here, and there's even more coming out here, including these two here, which go up to the capacitor bank. The external battery pack is a much simpler affair. There's certainly no microprocessor in this thing. There's just a TDA286A, that's the only chip on here. Both of them have these battery thermometers, which are rather interesting. Just a BC546 on a little board. Apart from that, there's a bunch of transistors under here. This large transformer isn't just a transformer. We've got the mains transformer over here, which has two taps. You can run it at 240 or 220 volts. You change the neutral tap over here, and this large choke on the black and the white connections, which goes down to here. And as you can see, they are actually welded on a single metal sheet, rather than two separate transformers. This one, because it's got the 8 batteries, you have a set of 4 down there, then you have, like the other one of these metal top lids, and then another set of 4 on top, and they all strapped together with a heavy duty band. And to give you an idea of the age of this thing, there we go. Tested in 96. June 96. So just coming up to 22 years old. One more thing before I turn it on. This is the battery breaker. It's a Crabtree Polestar, just a C32. It's not got any DC ratings at all on the side. It's just AC rated, and it's basically a slightly wider version if you compare it with the Lodestar, which is a standard MCB. You can see it's about 50% wider, and it's got a higher fault current rating. These are 6,000 amps and these are 15, I think. 16, sorry. Anyway, let's knock the breaker on to start with on the back. These can be quite noisy, although they were, well, at least it was when it was running a telephone switch. It sounded like how you'd expect an electric chair to sound. So let's give it some mains as well. And interestingly, it's detecting mains, but it's not drawing any at all, presumably because it's switched off. So let's try switching it. Let's have a look through the menu. You can set the clock. Input, is that showing the live input? Now I think it's showing what it's... Oh, there we go. Yeah, there we go. Although I suspect it's not actually 240 because it never is around here. Battery voltage, so let's put this on charge. There's quite a bit in there. See how noisy she is. Do you have to press and hold? Yes. Doesn't sound very healthy, does it? These things always sound like that. You can see even without any load at all, it's pulling 160 watts. If I give it a 100 watt lamp, turn that off as well. So interesting to see that the lamp on this one, it's not making any difference to the power factor, because presumably the lamp is actually running as a load on the output. Now let's see what happens with it running the lamp. To that waveform. Of course it might just shut down. The front panel is saying it's in inverter mode now. That's back on the mains. And we're back. Now let's see what happens if we load it to the max, where instead of having the 100 watt lamp, we'll take it to the limit with a 1000 watt lamp. Now of course there's going to be inrush with this as well, so it might not like it, it might just shut down. It's running it, but not very efficiently. You see we've now got 1200 watts in, 1000 watts out, so it's not the most efficient of UPSs. The waveform is absolutely rock solid, it doesn't seem to make a difference. In fact, it gets slightly quieter when it's running the lamp. If I take the mains off now, we know these batteries are on their last legs. We've seen them run for literally seconds. So let's see. Yeah, it's not happy. So let's put the mains back on. And the lamp's back on. So an interesting unit. Useful for load shifting? The extension cab certainly might be, because that's a 1000 watt charger it's got on the back. But the unit itself, it's not the most efficient, and you'd have it sounding like this all the time. Where it's sitting, you'd listen to it, and if it's got switch mode loads on it, it sounds even worse. But an interesting machine nevertheless. Last but not least, we have this beast. This is an Uninterruptible Power Supplies Limited PowerWave 3000T, which is a rebadged Power Value 11 from New Wave of Switzerland. A friend of mine picked this up second hand, sold as seen for 10 quid with completely knackered batteries. So I bought it off him, sold as seen for 10 quid. It's a little the worse for wear. It's got a few cracks in it. Oh, by the way, I forgot to mention, this thing is rated at 12 kVA. This would run the house. You can run a shower and this would happily run the shower and the rest of your house. It's a monster. And just to give you an idea of size, this thing is 32 inches tall. That's about 81.5 centimeters. It is a monster. Comes with an unblemished service record, because it was installed and then never serviced. So we've got a blank service book here. Manual, which I've printed out. We've got provision for an SNMP management card, so you can plug it into the network. RS-232 communication, various connections showing whether it's mains failure or various alarms, low battery, or whether it's on load, or it's also a connection if it's running on generator. And there's a remote shutdown connection as well, which I assume is this link wire here. Take that out, off it'll go. Batteries are connected through these fuses. There's a bypass fuse as well, so if you're running the system either in economy mode, so it's sitting alongside as a line interactive UPS rather than online, then there's a fuse there. And there's obviously these ones as well for the rectifiers. There's a maintenance bypass breaker, which would normally be off, and there's the input fuse. Sorry, that's the output isolator there. And as I said, you can see on the back it's branded up as a power value rather than the 3000T. Now, obviously a UPS this size is meant to be hardwired. You can see you've got connections here for an external battery bank. It's normally got the batteries inside, I'll show you shortly. There's the terminals for the output, there's the input terminals, and this is the bypass connection as well, so you can run it, you can run on there. So this is providing the supply for the running the UPS itself. The load will come directly off the mains, and if there's a mains failure, it'll switch in. Basically like a standard line interactive UPS. If you're using just these ones instead, then it's a purely online UPS. Interestingly, the maintenance bypass is actually single pole. It switches in this one. The left hand one is used, it's got these skinny little wires in here, you can barely see. You see this red one here, just for monitoring the status of this breaker. And mains input live, besides dropping straight onto the board, goes up to the maintenance bypass breaker, and the input neutral goes through this CT down to this panel here, and then it goes up to the right hand fuse and the right hand pole of the output isolator. So the neutral is coupled straight through. There's not much else to see on the back. The two 24-volt fans just blow air through this large heatsink, which goes the full length of the panel, and we've also got vents here as well. So what have we got here? Well, there's a massive capacitor in the middle there, which has been discharged for a long time. That's rated at 400 volts DC, 250 volts AC, 200 microfarads. And there's a big contactor here as well, taking the power through to the other side. There's connections going across the top as well. We can just see there's a bank of capacitors up there. This strange contraption has a whole load of ferrite cores in there, and over here we have a similar setup with less cores, and there's two of them, but they're mounted on one of these. Again, they're mounted in the same format as the other one. And at the bottom we've got 3 battery trays, and in fact if you look through there's another 3. We've got 6 battery trays. This thing, and the reason it's not got any batteries in it now, it uses 46 batteries. In fact, it came to me with 46 batteries in it, which were all old and knackered. It can be configured for between 30 and 50 batteries in series as one big long center tapped string. Now the batteries I've been using to test the other UPSs were 12 years old. They didn't have a lot of grunt in them. You can see as soon as I got them to do very much at all, they just packed in. But it still pack a lot of punch if I connected them all in series and accidentally got a belt off them. I mean, 46 batteries, you're getting not far off London Underground train voltage if those things are fully charged. So I have no intention of killing myself with a set of Duff batteries. So I'm not going to be testing this one in its capacity as a UPS at least. And for that reason, could you really consider this one as for load shifting? Well, if you could get hold of cheap batteries, then yes. The charger in this, according to the manual, is rated up to 6 amps. That's 6 amps at a good few hundred volts, up to, in fact, up to 700 volts or so. So that's a 4,000 watt charge. So if you're running on economy 7, you can pull in a lot of units overnight for discharge during the day. But like I said, you've got to be able to get hold of the batteries cheap. And obviously when they, you're not going to want to use this with a set of Trojans, because you're going to bankrupt yourself with with between 30 and 50 Trojan batteries, not to mention the fact that they're all going to be in series. That's a very dangerous battery pack to be meddling with. Anyway, that's the lot for this side. Let's take a look around the other side. So around the other side, there's not a lot to see until I take that panel off. Again, you can see the other set of battery trays. Each tray will hold up to 8 batteries. I think you can probably get the other 2 in at a push. It came to me with 2 batteries short, and it was configured that way anyway. But in here we have a latch. Which pops that down to the second position, and then the open position. And here we go. The capacitors we could see at the top are 1000 microfarad 450 volts, so they're not as beefy as the ones in the Silicon I took apart, but they're still, you wouldn't want to mess with them. We have a couple of big DC fuses and connections which are marked up IGBT. Oh, I wonder what could be behind there. And one of the few transformers you'll see on this board. And somewhere in here, obviously that looks more like a conventional mains transformer. There's a larger ferrite one there. So somewhere in here it's managing to shift an awful lot of power up and down. But remember, this thing runs, it's got a high voltage battery pack, so it doesn't have to step down an awful lot. It's got to step down to drive some, drive these logic boards, but the main UPS side, the business end, is all running at high voltage. So anyway, we have some more. What we've got here are a couple of relays. These are capacitors. There's one on the other board. They're 400 volt, 15 microfarad on that side, and that one is a 1200 volt, 1 microfarad. Those red capacitors are 220 microfarad at 385 volts. So we've got a bit of switching and filtering going on there, and something controlling them. What we got? Oh, there's an LM348 in there. It's so in amongst all this heavy lifting stuff, there's an LM348. There's a, what's that one? It's an LM339, I think that one is, and a few other bits and pieces. And interestingly, you'll see that there are some sections where there are identical paths, but only one is populated out of the 3. You can see there's one chip there. These are vacant. That row is present. These are vacant. And that's because these boards are, well, these UPSs, there are 3 variants. There's a single phase in, single phase out. There's 3 phase in, single phase out. And there's 3 phase in, 3 phase out. So this one is a single in, single out, so it doesn't need the additional input circuitry there. That capacitor, I suspect, is a much lower voltage. Yeah, it's 10,000 microfarad, 35 volts, and there's a 3300 microfarad, 35 volt one here, and another 2 there. So there's lots of low voltagey stuff here. What else is there of interest? There's an Infineon SAF C509LM there, made by Siemens. There's 2 lattice chips here. Let's peel this label off and see what's inside. An ISP LSI 1032E and an ISP LSI 1016E there. And of course we've got an EEPROM, so this is definitely not in-system programmable. This is a 2 megabit EEPROM, and we have a timekeeping RAM which also has 8 kilobytes of non-volatile RAM storage as well. Now, it'd be interesting to find out what's on there, those, wouldn't it? Because that would give a clue as to what it's capable of. And of course that's exactly what I've done. I've ripped the code from the EEPROM and the EEPROM, not to disassemble, because I didn't know until just now what that was, but just to go rummaging through to see if there's any interesting text strings in there, to see what options it's got and what error messages it can come up with. And you can see it's got a whole bunch of stuff in 5 different languages, namely English, French, Spanish, German and Polish, and the same ROM is used for anything from the 7.5 right the way up to the 40 kVA model, and that's actually selected in the menu then, along with the number of battery blocks and so on. That's all configurable in the service menu. Now it'd be interesting to get a little deeper into this thing. I don't particularly want to trash it, just to find out the model numbers of the various thyristors that are in there. You can see over on this board, great big thyristor pack there, and a smaller one in there. And this has dual connections, so it's going to be dual SCR, I think, in there. And same for that. Well, IGBT, sorry. Oh, this one's marked GT. That'd be a gate turn-off thyristor, whereas this is an IGBT. Over on this one, again, we can see the New Wave branding on this, so this is definitely a New Wave UPS rebranded as UPSL and not vice versa. We have all these big, heavy thyristor connections. And unlike over this side where it shows as a single unit, it's showing these sort of independently. So I'm not sure what they are. Looking at it, mind, we do have solder connections on here, so it would not be easy for me to take this out. I'd have to unbolt those and desolder from these rather thick tracks in order to get that board out. So that is staying put and not tearing it apart. Yeah, I know, boo. So that's the inside of yet another transformerless UPS, and a surprisingly beefy one. I mean, this, what you're looking at here, basically is the electronics of a 12,000 watt UPS. So it's surprisingly compact. Connections wise, we've got those ones which came over from the top from the capacitors into, and they're coming down here. And the reds, blues and whites are all the battery terminals. The white is the negative side, the blues are the middle of the pack, and then the reds are the positive. So it's a center split or center tapped battery bank. There's another nice big fuse in there. Oops, dropped it. That's 690 volts, 16 amps. These ones are 100. Oh, and there's another one there. So of course, so this is dealing with the battery supply. Then this is taking the high voltage DC bus, center tapped to there, of course, and these components here. There's a matching set just up there. So I think what we've got is 2 sort of mirrored circuits, if you like, here, dealing with that, taking the battery voltage in, and doing I don't know what. I think these TT connections go off to the those inductors around the back. And on this side, the only inductors you've got really are these toroids. So there's not, if there's any transforming going on, there's not much of it. And this side then will be dealing with the AC side of things. And there's not a lot else to see without breaking it, and I'm not going to. Shall I wire it up and switch it on? Well, it'd be rude not to, wouldn't it? I've been having a bit of a play with this off camera and learning a bit more about it. Firstly, if you clear the clock NVRAM, the UPS doesn't complain about that at all. It just loses the time and just repopulates a lot of the NVRAM from scratch. Secondly, the last attempt at putting the password in, regardless of whether it's correct or not, is stored in the clock RAM. As you can see here, I did 7890, which doesn't appear in the RAM, but 3456, which was my second attempt, that does appear in the RAM. Luckily for me, before I did anything with this UPS, I dumped a copy of the RAM, and the password used before I did that dump was the last password to be entered on it before I had it, and presumably that was entered by the service engineer, because it's the correct password. Thirdly, that password appears to be hard-coded into the EEPROM. It's got a dynamic password option which you can turn on, but that can be switched back on if it isn't. Serial EEPROM, the little 8-pin chip. Operation-wise, there's a lot of leakage current, enough to trip an RCD if it's fitted, or dimly light a pygmy bulb if it isn't. Let's let this go through its initial testing. This seems to be the standard startup. And that's the normal running operation. That error has been superseded. You can see the bypass is okay. That's the latest error as I clock back through them. It just doesn't show the last one when it starts up. I can add a 1000 watt load onto that as well. And it's fine. This is without any batteries at all. Leakage current with the UPS off is about 14-15 milliamps, and with it on, we can see now why the RCD was so grouchy about it. It's right on the limit. In any case, the supply for this is supposed to be, according to the manual, single pole protected. You don't want a double pole RCD on it if it's running as a UPS. Apparently it does not like it. The neutral needs to be referenced back through the main supply back to earth. With the UPS off and no batteries to charge, it's pulling about 43 watts. With no load, but it's prepared to run the load, it's pulling 233 watts. Well, the battery buses don't seem to be doing, you know, they're bouncing around like sort of 50, 60, 70 volts. So presumably it's because there are no batteries there to charge. So it doesn't. It's not going full whack on the batteries to try and charge them. Let's give it a 100 watt load. And put another 1000 on top. At least the waveform is nice and smooth anyway. Now this is where the eco mode comes into play. You see, at the moment we're running the load through the UPS, so any power blip, the UPS would soak it up and there's going to be no change to the load itself. And if I go into the menu, and go into commands and choose load to bypass, watch what happens to the power consumption. So we've just shaved that off now. It's now running on bypass instead. If there was a mains failure, it would cut back in. If you've got a load which can handle that, and many loads can, then it's going to behave just the same as any cheaper UPS. Now it's realised that the batteries aren't there. And the battery voltage, the bus voltage, is creeping back down. And presumably that's a sort of safety feature because it's allowed to have a variable number of batteries fitted. That's very low for what would be two sets of 15 batteries in series, because this is for one set of batteries and this is for the other. But let me show you why. And if I go into the service menu now, I can change the battery type. And change the overall autonomy and number of battery blocks. Now it says 23, the unit takes 46. That's because it's got two separate sets of batteries. It's got a negative, then 23 blocks later you've got the center connection, and then another 23 to the top. And the manual says it can handle between 30 and 50. So that would be between 15 and 25 on here. And it's currently set for 23. And you can see it's got the floating voltage there, and the battery minimum threshold is 242. Now, interestingly, I can change this way beyond what the UPS manual says it can do. That 30, that's 60 blocks in total. If I come back out, that'll update shortly. You can see the battery minimum threshold is now 316. Floating voltage is now 406. So it's adapted itself to handle what would be in total an 800 volt battery bus. And if I go the other way, that's the fast charge option, so if you've got larger batteries you can charge it up a lot quicker. I can take this right down, and that would be the minimum it says in the manual, and if I select that I can now come up, that will correct itself shortly. Battery minimum threshold is now 158 volts. Float voltage 203, so it's a 400 volt battery system now, 200 volts aside. But I can go further. That's the minimum in the manual. The settings menu lets me go right down to 5. Battery minimum threshold is now 52 volts on each side, so 104 volts total, and the floating voltage is 67, so it's a 134 volt battery bus now. Does it work with that? I don't know, because the batteries I was using for testing the others, since I tested the others I've actually got rid of the batteries. I gave them to a mate of mine who runs a garage, and he scrapped them along with a load of car batteries. So I don't know. But if it does work with that, then that makes it a lot more potentially usable as a load shifting UPS. Obviously the amount of power you can charge it with is a lot less, because you're talking 134 watts, 134 volts at up to 6 amps depending on the batteries. That's only 800 watts. So I don't know. Anyway, let's come back out of there with that set like that. If I turn it back on, is it going to grouch and say it's saving the configuration? It usually seems to. Yes. But the chargers are running at about 90 volts there, so it does seem that the minimum you can set in the menu isn't the minimum it'll go to. So if you take it to those oddball, way out of design range settings on the board, it's not going to do what you expect. So 30 batteries minimum, which if you can afford the batteries and turn fast charge on, would give you about 2.5 kilowatts of charging. So that was the last of the UPSs to look through today, with quite a bit of detail on that last one. Hope you liked it. Thanks for watching. I'll see you soon.